So I get downstairs in the morning, and my kitchen has an alarm. And it sounds something like this. Meow! 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 The cat really does think it's a dog, and it loves food. So I want to talk about the early universe, and it really is the good place to right over there. So I'll do it anyway. So to give you an idea of just how dramatic the universe is. So I mean, there's a lot to talk about in this topic. There's incredible complexity, incredible stuff going on, but I just want to give you a sense of what the early universe was like and how amazingly complex it is. So in the first 1 billionth of a second, there's this thing called superinflation. The laws of physics were literally themselves in flux and change. They hadn't settled down. Kind of like if you were to take a ball on some really wavy surface. You know, if you drop the ball on it, eventually it'll find the lowest point, right? Well, what if you start shaking that up, and the lowest part keeps moving around? That's what the early universe was like. The laws of the universe hadn't settled down. So in the first billionth of a second, the universe dramatically inflated. In fact, it inflated to 1,000,000 billion. I'm sorry, there's another billion.
Watch your footing.
Thanks. 1,000,000 billion times its size. Something from nothing, at least for our scale. You know, we don't normally deal with sizes and times that small. So just amazing change. Before, when the universe started, now we talk about a billionth of a second in the superinflation. That's just getting the ball rolling. Now, if you've ever had a really hot soup or something, everything mixed together, and just, I guess soup is a hard thing to describe, but everything mixed together, maybe a chemistry solution or something, you can't pick out what's what because it's all melted together. And as it cools down, you can start to see things solidify. We've seen crystals form as water gets colder. Well, that's another thing that happened. As the universe got cooler, something started to emerge from this soup. I mean, literally, it was so, we all know what electrons and photons, protons and neutrons are. They didn't exist. It was too hot for those things to exist. And if you think of all the atoms in here, it's not that the atoms couldn't come together to make this. It's that the constituents of the atoms couldn't come together to make atoms to make this. So as that soup cooled, photons began to emerge from this. Oh, let me take a quick divergence. If there's a photon created in the center of the sun, it takes 10,000, I think about 10,000 years for it to actually emerge outside of the sun. That's because it keeps bouncing off of other photons and other things in there. That's called opacity. It's just, it can't get out. There's too many things to bump against. So that's what the early universe was like. And it took 375,000 years for the universe to cool down enough just so that light could emerge and be seen. Not that there was anybody around to see it at the time. And it took another 25,000 years after that. So we're now at 400,000 years after the universe started in order for things to cool down enough for matter to start to form. just simple matter. Eventually, because of micro differences in the density of matter, gravity would start to emerge stronger in one place than another. And as the universe expanded, those micro differences became more significant. Matter started to clump together. As matter started to clump together, the differences started to become greater. Matter started to clump together more. Stars started to form. And now we're talking not just hundreds of thousands, we're talking millions of years. The universe, by the way, is about 13.7 billion years old. So, in our star, our sun is about a third-generation star. So what happened is matter started to clump together, started to get back in these hot balls where everything was bouncing against each other, just like the light couldn't take so long to emerge from our sun. That started to happen again. And stars started to form. Eventually stars would explode, and the matter would be dispersed locally in the universe. The cycle would happen again. Like I said, our sun is about a third-generation star. But this all started from this immense seething beginning where things, unimaginably important and dynamic things happen in a billion, billionth of a second. So, to reference Stephen Hawking, that's a brief history of time. And I just wanted to give you a sense of what the early universe was like, and then we had a moment to progress on to how that kicked off the universe as we know it. And I'll conclude by saying it's a darn good thing, because without this, I'd have nobody to talk to. So thank you very much. I hope you enjoyed today.